It's guys, here we go back to another video. Today, guys, I'm gonna be going over problem number 2 from the last AP Physics test we had, which was on gravity and satellites. And I, the way I understand it, problem number 2 was pretty challenging for many people. So I'm just gonna be showing how to do that in today's video. And yeah, without further ado, let's get right into it. All right, guys. So the problem is at the top right here, top of the screen, and let's just get right into it. So a system of 4 stars of mass m each forms a square. Okay, so let's draw that out. 1, 2, 3, 4 stars, all of mass, equal masses, m. All right, so they all form a square. The entire system revolves around the center of the square. All right, center of the square here. They're all revolving around the center of the square, like that. So this way, like that. Perfect. Maintain the distance of between the stars constant. The diagonal of the square is r. So this value right here is r. Now we know that since this is a square, this angle right here is going to be 45 degrees. This angle is going to be 45 degrees. So these sides are going to be r divided by, well, no, r divided by square root of 2. So each of these sides is going to be r divided by square root of 2, because that's just 45, 45, 90 triangles. It's x square root of 2, like that. So just divide by square root of 2 to get side lengths of these ones right here. Voila, just like that. Now, I'm moving on. A, find the angular and linear speeds of the revolving stars. Express your answer in terms of m, r, and the fundamental constants. Here, draw a nice clear diagram. We have it here. It's not very clear, but it's there. And then voila, show over partial credit. So we know that the stars are moving in circular orbit. We know that, so it wants to find the angular and linear speeds. So to find the velocity first, we know that this is gonna be a force problem. So force equals mass times acceleration. In this case, acceleration will be centripetal acceleration because they're all moving around center of mass. Centripetal acceleration, which is also equal to m v squared over r, because that's just a centripetal is v squared over r. So this will help us find the linear speed right there. Now, so, oh yeah. Now, so we know that's a force, and we know that the force acting. So we'll take one of these planets, for example. The force acting on this planet is gonna be the same as the forces acting on this planet, the same as this one, as the rest on this one, and the rest on this one. So we just have to find the forces acting on one planet. In this case, we'll take this planet right here. There's a force coming from this one right here, which is gonna be since there's these two, it's gonna, the net force is gonna be going this way. Therefore we know you're gonna have some cosine 45 involved somewhere. So in this case, we'll have the force from this one right here. So force equals on this one's gonna be so again, g m times m over r, in this case r over square root of 2, parentheses squared, and then plus, cosine 45, because it's this way and the net force is this way. So cosine 45 is pulling away from the net force. That makes sense. And then we're gonna have two of these because there's both those, and then plus, I know this is sideways, guys, and I apologize about that, but plus then the one from here, so plus g m over r squared. All right, and that, guys, will be the first equation. So here I'll write it down like this: I'll do m squared over r square root of 2 squared cosine 45 plus g m squared over r square root of 2 parentheses squared. And this, guys, by the way, this is just the equation g m m1 m2 over r squared, by the way. That's just that equation, just rearranged. Cosine 45 plus g m squared over r squared, because that one's just that one pole in the same way as the net force. We don't have to like do any cosine or funny business there. Now here we can cancel out one of the m's, so we cancel out the exponents in each one, just because, yeah, math. And then this r value is going to be the radius of the whole thing, so it's going to be 1/2 r. This is going to be 1/2 r. Let me just r radius equals 1/2 r, because it's going to be half the diagonal. It's going to be the radius, so it's going to be 1/2 big R right here. Now let's just do this one, expand this, so we have v squared now over 1/2 r equals g m over r squared over 1 is 1/2 r squared cosine 45 plus g m over 1/2 r squared cosine 45 plus g m r squared. So now what we can do is we can write this out again in a different way. So here we have what's calling for anything? We have gm over r, gm over r, gm over r, and everything. So well, gm over r squared even. Oh, gm over r. Yeah, we can do here. We'll do this. Velocity squared over 1/2 r equals gm over r squared times 1 over 1/2, so 2 times square root of 2 over 2. 2 square root of 2 over 2 plus 2 square root of 2 over 2, same thing, plus 1, just like that. This is going to be plus 2 square root of 2 plus 1. Now, sorry, from here we can multiply both sides by 1/2 r to get, multiply both sides by 1/2, multiply both sides by r to get this out of there. We're left with 1/2 of that. 1/2 of that. Which gives us velocity squared equals 1/2 r. Multiply both sides by 1/2, we get 2 root 2. What do we get? Root 2 over 2 plus 1/2. So g m over r times 2 square root of 2 over 2 plus 1/2, because of just multiply both sides by 1/2 here, 2 root 2 over here, you get that. So we know that velocity, so I do this up, velocity equals just do that out, square root of g m over r times square root of 2 plus 1/2, guys. And that's gonna be the linear speed. And now to find the angular angular speed, we know that that angular speed is gonna be the velocity over the radius. So we'll do radius, so 1/2 r in this case, which is just gonna be stage change. Oh, sorry, I'm writing this sideways, guys. You're just gonna be used to this. It's going to be square root of g m over r times square root of 2 plus 1 half over r over 2. So just state change flip, we can just come down here to get the angular speed. It's going to be 2 over r square root of g m over r times square root of 2 plus 1 half. Alright. And that, guys, is the answer to question number 2 from the last gravity tests. Alright, guys, thanks so much for watching. I hope you enjoyed that video. I hope that I could help in any way. If you have any more questions, please feel free to let me know. I'm pretty sure on time, so I don't really have time to go over the whole test. I gotta get some studying done and I got some other work done too. But I hope this helped. Just always remember, guys, that those forces have the just always remember the cosine 45s in those, because I'm sure that this question will likely come up on the next one. So just remember about the directions and remember the equation for forces, and you'll be set. All right. See you guys soon.